Thank you for joining this glTF virtual meetup. Joining us for today are Max Limper from DGG and Norbert Nopper from UX 3D. First, a couple of housekeeping items. If you have any questions during the presentation, please ask them using the Q&A feature located on your Zoom toolbar at the bottom of your screen. We are recording this webinar and we'll share the link along with the slides and the recording shortly. At the end of the session, please complete the short survey form to help us better design future events. On today's agenda, Max Limper will show us how to get CGI content ready for real time with glTF, and Norbert Nopper will demonstrate staging glTF for the metaverse. Now let's start the web meetup with Max Limper from DGG. Max?
Yeah, thank you so much, Jeff, for the nice introduction. And happy to dive right in. So real quick introduction about myself, and then also of course about the topic. So what are we going to talk about here? CGI content, as one of the most popular data sources for 3D and commerce especially, and at Khronos we're very interested in 3D commerce. We even have a 3D commerce working group, right? So I'm going to focus pretty much on that. And we can see that this process can be divided into steps, which is first creating a glTF file and then translating that to an optimized representation that we can use everywhere. So quickly about me, I like automating 3D workflows at scale was always like my passion, and that's what I've been doing for the past couple of years. I'm co-chair at the Asset Creation TSG at 3D Commerce at Khronos, and also co-founder and CEO at DGG, and we create a software called Rapid Compact, but I'm going to talk more about that later during the presentation and show an example. So diving right in, if you look at classical 3D workflows for e-commerce, then you will see that the most prominent use of 3D technology in e-commerce is actually generating nice pictures for your catalog, right? So these catalog images usually come from an offline rendering, like a CGI model that is rendered with some software like, let's say, 3D Studio Max or Blender or Maya, and using some renderer like, for example, V-Ray, that then generates a picture in 5, 10, 15, or 30 minutes, or however it takes, like whatever it takes to generate a high resolution photorealistic representation from one view that you can use in your catalog, right? And that data is usually stored in some kind of authoring format. So you can open the scene, make changes, and render it again. That, however, is not anything that we could use in real-time applications, right? And you can see some examples on the bottom, like let's say we want to render the asset on a mobile device, on iOS or Android. We want to use it maybe in some floor planner, maybe in a web catalog, and so on. And all these different applications have slightly different requirements on the data, right? When it comes to like file size, polygon count, texture resolution, etc. And at Khronos, we have thought about that, and I'll give an example of like how we have helped there and how you could possibly also benefit from that and contribute to our efforts here and help us as well. And before talking about that, just again recapping the two steps I mentioned in the beginning. So if you have that offline model, the first step that we have to look at is how can I get a real-time asset that might be too large, but that is something like the ground truth representation, ideally already in a format like glTF that I can then use for all further steps downstream and create these different optimized versions from that real-time base asset with PBR materials, right? So we're going to focus pretty much on that second part here. And Norbert is also going to talk about staging glTF for the metaverse. And I think like this whole workflow is super interesting. There are many data sources that can be used to create a glTF model. Again, like we are usually focusing on in our daily work, working with retailers on this workflow where you have a CGI asset and then you translate it from a 3ds Max scene somehow to a glTF representation, for example, right? So let's assume we have that. Then the question is, what is the right resolution? What is the right polygon count, texture resolution, file size, etc., for a certain platform? And There's of course no perfect answer to this, and you can always optimize further. New devices are showing up and the bandwidth increases globally and so on. But we have thought about like the current status and came up with something that we call the 3D Commerce Asset Creation Guidelines version 1.0. And you can see that online. If you look for it, it's on GitHub, and then you can even like contribute to it and comment, and it, for example, elaborates a bit on these topics, and like using some average bandwidth that is assumed, we can derive from that, for example, if we want to see the asset on the screen in at maximum 3 seconds in an e-commerce scenario, then it might make sense to have a file size that is not larger than 3 megabytes, just as a rule of thumb here, and so on. So this can be a starting point. As said, you like are free and like invited to optimize this further for your particular targets, but we can already use this as a rough guideline to understand the order of magnitude we're talking about, right? So 30 megabytes nowadays is usually a bit large for online shopping. 3 megabytes is round about the right range, just to give an example. And like, let's look at a very particular example and dive a bit deeper into like what glTF can do and how it works. So here's an example that we actually made an official glTF sample model. So it's a like fictional product. So we made it up specifically for this purpose, but it's inspired by these lamps that you can actually find in real shops. And yeah, you can use it to like perform tests or like, evaluations of any kind. And it's in the glTF sample repo. So this asset was created by one of our artists using Blender to create the actual like geometry and like assign the textures and UVs. And then Gestaltor, which Norbert will talk about also in the second presentation, in order to get the glTF extensions correctly assigned. And what you can do pretty cool things with these extensions. So for example, here they're focused on the actual function of the lamp, which is of course like making light. And glTF has a pretty cool extension for that. If you want to have a point light, it's called KHR Lights Punctual. And that extension was added here to make the lamp emit light here. And then that adds this nice effect that you can actually see here how this part of the lamp like gets lit by the bulb, right? At the same time, it makes a lot of sense that we can see the light here through this shade, right? So the lampshade has to be semi-transparent, and for that, there's also an interesting extension. It's the KHR Materials Transmission extension that allows us to add, for example, like reflections on a material that is transparent, semi-transparent, and yeah, adding a bit more realism there compared to just using alpha blending. And both of these extensions, as all glTF extensions, are kind of optional, right? So a viewer can implement those, but it's not a hard requirement. So that is something that allows us to basically distribute the glTF assets almost everywhere. And all the series viewers are implementing these extensions. But we have fallback mechanisms also in place for example, devices that wouldn't support them for whatever reason. And in this case, they are very commonly like supported. So we can get this nice effect here. And we also see some examples how this asset looks like in different viewers in just a bit. So if you want to try that out yourself, like the next step, we're going to optimize the asset with Rapid Compact for like a banner ad in this case. You can download the high-res version here. There's also a short link, and then you can try it out. So usually we had like a bit less time scheduled for today, but since we have a little more time, I'll even do this as a live demo and show you how we can do this with our Rapid Compact platform and how we think about like this whole workflow. So what I'm going to show is, if everything works, that like you can upload this asset and then generate different kind of optimized versions for different platforms and leverage glTF for that. So I have the glTF model here. I'll drag it here. It's a bit over 20 megabytes, has like large textures and like a bit higher polygon count, and yeah, was created in Blender, right? And then as said, like the extensions were assigned using Gestaltor file. So our server you can upload your asset, right? And then what I just wanted to show is like you click here on banner ad, right? And then it will start the optimization of this asset for this particular platform. It's usually quite fast, and we can even spin up some more. And let's say, okay, I want it for Spark AR, I want it for Lens Studio, and for like Unreal Engine or whatever. And then you can see here that there are some processes running, and the first one should already be finished by now. So you can see here, okay, that's the 683 kilobyte asset that came out. You can see it here in the viewer that shows this asset, and as you can see, the extension got preserved, and we could embed it now and show it in the website, right? Or like do something else with it. And you can also download the resulting files. In this case, the preset created the GLB. That's what this is all about. And of course, we are all aware that there is another kind of de facto standard out there, which is being used on the iOS devices primarily, right? Which is called USD or USDZ in this case, this variant that is zipped, and naturally you want to produce those as well. But I think glTF makes a pretty nice base asset format as well. And what we can do here under the hood is again leverage all the capabilities of glTF. So not only optimize the mesh and the texture resolution, but also add compression like Draco by Google, which is also available again through an extension, or the KTX2 container that allows you to compress the textures in various ways, right? So we have done all of this here and ended up with this very optimized compressed representation that loads 32 times faster than the original, which is pretty nice. And again, you can try it out yourself and also optimize for different platforms. And I've actually done this here with this asset and created, for example, a version that I can use in PowerPoint here, which is possible with glTF. However, this one doesn't support the compression, for example. It also doesn't support the point light extension, apparently. So here the lamp, unfortunately, is always off, not on. And however, if you use, for example, Microsoft OneDrive, which I think is based on Babylon.js, the viewer there, then you will be able to see the lamp also on. Same with like in the 3JS viewer, for example. And I also tried it out, and put it into like the AR core scene viewer here on Android, or into the model viewer, like editor here. And that's really the cool thing about glTF. So here you can see it might look slightly different, but it's pretty cool that you can show them on in PowerPoint, right? And it's only possible so easily to do something like this with glTF. So that's really why we call it the JPEG for 3D, since it's supported almost everywhere. And I'm sure we'll see more adoption of, for example, extensions here in AR core scene viewer. So that's just a matter of time. And by the way, PowerPoint was the only one that didn't support the compression. Like all the others support the compression already, for example. So just to wrap it up, what we have seen here in this really short presentation was that we can get CGI content ready for real time and get it to all kinds of different platforms with two simple steps. The first one is creating a high resolution glTF file that then deals as works as the base asset, and is then key to getting it to all these different platforms, which we can do by creating an automated pipeline to optimize the glTF data for publishing. We have seen that the publishing targets, the asset creation guidelines from Khronos, actually can be helpful if you want to understand the rough recommendations, what mesh resolution, etc. Texture resolution is suitable. And then there are also fallback mechanisms for 3D viewer conformance in case extensions aren't supported. So you might want to test the different assets in different platforms before deploying. And finally, key to doing all of this on a large scale, doing it efficiently, is having an automated pipeline for 3D data processing and optimization. And we've looked at an example for that, and I think Norbert will also talk more about these kind of aspects in his talk. So I'm really looking forward to that. And about staging glTF for the metaverse. So Norbert, over to you.
So welcome to my session. So let me share the screen. Yeah, what I will talk, as Max already introduced, I will talk about staging glTF to the metaverse. I try to explain, or I want to give you a glimpse, like to understand what we understand with staging, because it's used in different manners. And then to the metaverse, of course, I will give her no lecture about the metaverse. I think there are enough books, there are not enough articles, but I think I try to bring over the challenge in general. What have you do when you want to stage glTF of the metaverse? So let's call this the agenda. So it's the sub-agenda of my presentation. So I give a short introduction of myself, then the road to the metaverse, like a one slide or a high level. Then I want to tell you why glTF staging makes sense. And the largest part about glTF staging challenges, what are the challenges in general? I think Max already mentioned some of them. I will enhance some of them. And last but not least, of course, we as UX3D have software for this as well. And yeah, let's start with the first slide. So short introduction for myself. So I'm Norbert Nopper. I'm co-founder and managing director at UX3D. To the right, you see the typical icons I use on LinkedIn, and on the right, it's on GitHub or wherever. So whenever you see these icons, you can assume this is my identity, not yet in the metaverse, but in this virtual entity in the internet. I'm a software engineer by heart. I studied computer science, and over time, I focused on GPU software development, and that's the reason why there's UX3D. So mainly we're doing projects, glTF and interactive 3D related, like, of course, not just glTF, but as we are like, or I co-specify glTF, it's like, it's clear close that we have tried to do everything with glTF. And like after a lot of projects, we decided to create a product. And meanwhile, we have a product line for Gestalter. So many of you guys probably know the Gestalter desktop. You see like a screenshot on the left side. But because of customer demand and requests, we created Gestalter Automated, but later on this more. And of course, there's more to come. But let's go over now to the interesting part with glTF. So road to the metaverse. From my perspective, the future of glTF is driven by many use cases in industry. Like the most people know, you have 3D commerce. You want to display furniture or apparel. Then a 3D user interface. That's really quite common now in automotive. If you have a dashboard, like there's already like a 3D user interfaces on the road using glTF. Then computer games, like web games, or it's like even like PC games or whatever. Then geospatial is a big topic for this. Social networks, of course, like interacting in virtual worlds. But I think what's really important that there's a question mark and exclamation mark at the bottom. There's a lot more to come. I see it as an involvement, as it, from the bottom up, and then things go. And I see an intermediate step that we say, okay, all of them, they want to have a digital twin. So you see a lot of glTF, you see a lot of digital twin naming. And the point is, if you Google it or if you look at Wikipedia, what a digital twin is like, of course, it's the visual representation, but you also want to have a physical representation, so it maybe interacts with the environment, or it has some behavior, and much more. You want to have an entry point where you want to put your glTF at some place, and yeah, today more than 100 ratified draft experimental GF extensions are out there. I don't know if you know this, so. Of course, because we do have a glTF editor, I'm keeping track of which extensions currently out there. And in the list, there are more than 100 ratified draft and experimental GF extensions. And of course, the goal is to consolidate glTF extension for an open metaverse. And there's also like this metaverse standard forum, and probably we have to expect more to have connection to USD or other file formats and so on. And out of this, I think there will become like, you have like a metaverse, an open one. We have interacting digital twins for persistent, connected, and decentralized 3D platforms. This is my abstract sentence if I have to explain what we are doing, because metaverse is even larger. But I think it's important that you have interacting. So you have a if you have a pen and you put it on a sheet, it should be possible to draw with this pen. So you're interacting with one asset to the other. Persistent should be always there. and connected. It's not just like one platform where you go and you put all your content on. No, you will move content to one platform and then this from one platform to another platform just by traveling. And I assume it will be decentralized like the internet is today. And to achieve all of this, it's like we're betting on glTF, and I think it's, as Max already said, it's the JPEG for 3D. And people asking often us, why glTF staging? And I like to compare it with a photo. So in a perfect world, a photo would be just published. So you see like here Angelina Jolie to the left, but in general, like there's a website where people like show how they look before and after Photoshop. But it's the same with products, you know, you tweak them, you improve them for whatever reason. If you have a 3D movie production, you have a post-production process. So it's a typical general. So just export it or generate the asset and just upload it, you're retouching it. And like some years ago, as we said, we believe that it's the same in happening in 3D, but meanwhile, we know the same is happening in 3D as well. Because you want to prepare your glTF for the final delivery and output. And the advantage of when using glTF, if you already know you want to deploy with glTF, of course, you can use USDZ as well as a separate path. There's some point where you say you don't want to leave like the glTF content anymore. Because if you have like a glTF data model, you have a lot of extension, whatever, extra data, whatever, and then you don't want to leave it. Because in general, and I use here from Don McCurdy the wording, you have f on x, for like the function from x is not exactly the same as glTF, it's approximately the same. So, and it's, the obvious one is like you just want to repair and clean up your glTF. And that's of course the obvious one, but that's the only one. And of course, like if you're in a glTF context and you have seen like Max Limper with the nice screenshots comparisons, of course there's the goal to have like a common output for the glTF, and like the 3D formats group, the 3D commerce group is taking care that this is really coming to a sweet spot where it's like 99% everything looks the same, but in the end it's like you want to see what you see is what you get editor. Because many cases, like you're editing in a different renderer, or it's like an offline renderer, and then you have these little details which are important, maybe not for casual use case, but for like business or industry, it's really super important that the visual output comes in. So they modify the glTF parameters, and then the point is people start like, okay, if I have already the glTF, I don't want to do this step again. They start to have a library. And then they say, okay, if I put, for example, a chair next to a table and a vase on it or whatever, or a boombox, people start to compose. And the point is back, why you say, okay, you can go back to re-import it again in your DCC tool. Of course, that sometimes makes sense if you maybe want to author on a general way the thing, but in some cases, you have spent so much time and so effort into like optimizing your glTF that you don't want to go back. So at some point you say, okay, my DCC tools, they're working perfectly. I authored everything, I exported everything, but at some point you're in the context of glTF and then you don't want to go back to the space. And last of the, I already said it, you have a glTF library, so people are then merging it. So they have, for example, an empty glTF where you visually don't see anything, but they have their material, or they have their light there, or whatever, cameras, and they say, okay, I want to now do it. I take this geometry and have this material and just put it on. So this is called merging. And of course, splitting. This was quite new that this demand is that, for example, people, of course, there's a glTF extension for variant, but some people say, oh, I don't want to have it. I want, because my use case is, and then they want to split it up. And there's so many use cases if you talk to the customers, what they want to have. And they want to do it in glTF because they have the asset already in glTF. And the nicest feedback we get from our customers, it's a lifesaver for them in many cases. So let's put it like this glTF staging challenges. So what is it? I have to close the door because my kids are coming. Because normally I would have my headphones on and then you wouldn't hear it, but no, it's this. So glTF staging challenges, I call it the whole process. And of course, there's something before and afterwards. It's like this the staging thingy. And you import the glTF or you're loading a glTF, because we say it's a different if you like, as you see before, if you have the function, if you have just importing it. Then we are retouching it. So they use the same wording as for the Photoshop process. And last but not least, deploying to glTF. And that's normally where we stop. it's we are not directly uploading today like to any platform. We say, okay, there's a glTF, but we say, okay, if somebody wants to optimize in a specific way, you can do so. And the point is, that's the reason why we have a circle here where we say, okay, you're retouching in. Maybe it's not an infinite loop, of course, but you're like revisiting your glTF several times until you have to find deployment of a GLB or glTF. Good. glTF staging challenges, import and load. So now I want to give like the general problems and challenges what pop up. And also, like, if you have a pipeline or you have to do a similar topic, the main thing is you have different origins, and I think Max can give you more details on this. You have either, in my case, a scanned data, because that's a different, let's say, structure of the material, and then an author 3D data. So you have a different challenge to apply materials afterwards and so on. Then you have many different 3D industry and proprietary formats. So it's like you have meta information in scenes. So when we got in touch with customers, they are, let's say, meta information or scenes, which are describing like a scene where you say you have this FBX and you have this, and it's like, and this you have to bring in. Some folks have like materials and geometry split it. It's not always the case where people have say, okay, I have a FBX or a USD file and that all information there. No, people like somehow at a late stage, I want to merge the material with the geometry, and you have like a splitted data. And there's so many cases where this comes in. Then data security, that's a super important thing. I mean, sometimes people say don't export too good, and that's you have to take care, because in many cases you get original CAD data, and then of course there's the problem to have the danger of intellectual property and creation of a plagiat. Then the 3D format size, they're like what Max and Rapid do, you can optimize the geometry and images on the fly, like when you're doing the import process, so you can reduce the geometry and images. And then there's also distilling, and on the distilling say, or you're baking it, because if you know the target where you're going to, you can, for example, if they're in a USD file or in other file format, you can remove or adapt the subdivision purpose. So many cases where you say, okay, there's a GLTF coming in, and this now you have to retouch. And as I said, want to summarize it. So if you're using even our editor, but there are other tools out there. There's the Visual Studio Code. It's a text-based editor or whatever. But that's the typical thing when you're using these tools. What you're doing in the staging process. So you repair it and clean up a GLTF. Repair means, yeah, that's unfortunately sometimes the case. You get a GLTF where some data is missing, or it's incomplete, or it's even invalid. That happens, and it's a good case that you can repair, that people can still load it because they say, oh, I exported it from this tool, and now what I can do, I need it, and then folks open it in our editor, for example, and just save it, and they know it's 100% GLTF. Cleanup means, okay, sometimes you have empty nodes and a lot of structures which you don't need, which is just loading up your GLTF. And then modify GLTF parameters. What I said, it's what you see is what you get. Tweaks where you say, okay, this is like how it looks like when it's 3D commerce certified. Some cases, if the tool does not yet have the extension, you can add extensions. Then you can talk about merging and splitting. What I said is, so because in many cases you just don't get just one FBX. Sometimes you get an OBJ, you get FBX, because whatever use case these companies have, they have to do it. Because the reason is, in many cases, the 3D pipelines already exist. Okay, in some cases, they really build up the 3D pipeline from scratch. But in many cases, they already have a 3D pipeline because they have used 3D before. But the new thing is they want to deploy to glTF or create glTF and later deploy, like create a digital twin and later to the metaverse. And as I said, then people, you have different input sources, 3D metadata, then you have to create glTF libraries. So it's a common use case that you can have a glTF and it's valid to have just the materials and so on. That's nice. You can try it out in the validator from Alexei. Then you come to a point where you compose several glTF. What I said before with the table and the chair, you can put several GLTF to one glTF and deploy. That's, for example, you have a larger scene and you will say, okay, I have the chair, I have the table. Whoop, here's like the complete scene, maybe in a living room or whatever. And optimization, and here's Max, you can ask him, it's like you can improve like the image size and the compression format, and you can reduce the geometry size. But the point is like also like, and that's the point, just how exporters work, because you're projecting from one file format, 3D format, to the other one. You can eliminate and merge duplicates. And execution time is very important, especially for in the embedded area or mobile phones, because sometimes, for example, when you have an export, if you look at Sketchpad, for example, it's really great platform, but in general, you have like a long hierarchy tree where they're traversing or rotating from one axis to the others. And in many cases, you just need a root node and the asset, and you are avoiding like all this multiplication of the matrices to just have the final output of the transformation matrix. And these things in total, and also, for example, if you have a user interface, a 3D user interface, where you know the 3D camera is always fixed, you can, for example, order your glTF where you say, here's this node, and you don't have to do your engine to do the sorting for alpha blending, but you can do it by yourself, where you say, okay, I know how to go really exact, the camera never changes, and then you can always find improvements where you can tweak the speed of rendering and total memory. And then I'm already coming to the last slide of the staging process. And it's similar, like the point is, the challenge is really like the deploying process. And I want to extend it because for me, or for us, the metaverse is an input-output tag in the metaverse. It's because in the future, you don't know where your glTF will go to. More and more, the manufacturer will have like a product, the manufacturer, like the company, who has like the brand, but it can be also like the private person says, okay, I have a product in my mind, or I have a real product, and I want to deploy it to the metaverse. I want to deploy it as a digital twin. And then you have to test glTF in many cases, and that's the biggest challenge, I think, in the future, that you say, okay, I want to deploy this glTF to any platform out there. Most people are maybe associating glTF to web platforms. Most people know like Babylon.js and 3JS. But of course, like there are many other engines out there. And because my background is from the automotive side, glTF is mainly also used in automotive as well. And there are other businesses I even know, and I think they have also their custom engine. So you have already like a really big bunch of 3D platforms and engines and tools. And then you have to adapt to the output. You have embedded devices, you have a smartwatch, you have mobile, like a mobile phone, a tablet, XR, like the mixed reality or augmented glasses, which will probably sooner come up. Then you have a desktop, then you have a really CGI workstation to cloud and whatever else. And like all this combination is really challenging. And the really challenging also to glTF will be like to have the right extensions and the approach that you say, okay, you can deploy one glTF and that can be deployed to any platform. So now coming to last slide, and then I will do some demo time. So some software from UX3. We have Gestalter Desktop, so it's a glTF editor and stager. So there's version 1.0 stable and for production. You can download there. So with some circumstances, it's free. And we just launched Gestalter 2.0, which is pre-alpha and can be used for testing, but please don't use for production. And if you want, and it would be great if you can send feedback to us. And you can download a nightly build from there. The main idea is that from the customer feedback, as I said, we said, okay, we want to have your Gestalter, but we want to automate it, but we want to have it like in our IT environment. We don't want to have it in the cloud and so on. And as I said, okay, but we have this and this use case. And in the first step, we thought, okay, we have to implement this, but there are so many different use cases where we decide, okay, let's just put Python interface around it, where people can say, okay, you have the strengths and the power of Gestalter with all its functions, but people can now decide like what they want to do with how Gestalter should be processed. And they can individually adapt also like this tool to their existing 3D pipeline. And let me show this a little bit. So for Gestalter Automate, I think I'm running out of time. So if you see here like a short Python script, it's a stress test for internally where we're benchmarking how fast our functions are when we are like attaching like hundreds of glTF together. It's like like attaching, of course, a license you have there, and then you have creating an empty scene and so on, and then you're just making a grid of some spheres, and it's not optimized. As I said, it's a stress test where you say, okay, we just attach them together and together, that it's getting large, and let's see how the behavior is. So this can be executed. So let's do this. So execute it. So first it does a license check and so on, or it runs in the background, and it creates 125 assets. And the point is, it's not just creating it, it's putting together into one file. So it's created it, and it's created here. So that's the one. It has to write to the cloud. So it's local here. So I'm opening it now in Gestalter to inspect it. I hope you can see it. So this grid was created now with Gestalter Automate. It's a really basic sample. And well, for people who don't know Gestalter, it's like really like the GUI and all the context in the sense of glTF. So you can't do more than glTF, and you can't do less. The point is that you can't do like an invalid step and then suddenly it can be reproduced or be done or stored in glTF. So let's take, for example, this sphere. You can see it, okay, you see the translation of it, and you can have a look at the mesh, and you can see, okay, how is the wireframe, okay, how does it look like? And then you say, oops, there's large, maybe you should optimize them. Then I go to the primitive. And the point is, of course, you have to understand, and this we will improve in the future, you have to understand glTF, but if you're common with glTF, you know exactly what you're doing because you're navigating just the glTF with a nice GUI. And here's the material. And the nice thing here, we have all glTF extensions. So for example, let's get close a little bit to this sphere. You want to have a nice clear code effect on it. You can edit and you say, okay, what else do I want to have? Maybe residence is one of the latest ones. You add an residence effect, a subtle. Let's put here a strong IOR. And then you see, okay, it's getting this color, and let's put this here and like this. And that's the point where you can manually do this. But in the end, you can also do it with Gestalter Automated. I think I have taken now my time. So I'm stopping the presentation for now. I'm giving over to the general. So I stop sharing.
So yeah, I think we have some questions, and one about audio, which I saw, and another one, which app do we use for retouching glTF? I think Norbert answered that already, kind of, right, during his presentation. This question came in earlier, but Norbert, looking at that Photoshop example that you gave and this analogy, would you add anything here? Like, I suppose you showed how to retouch glTF also with these spheres.
Yeah, I think what's important is, like, I think the first slides for myself were like, let's say, independent from what UXG is to it, like the general process. That's the point how we see it. And at the end, we showed our product like Gestalter Desktop, where it's like a manual process. In the end, you have Gestalter Automated, but as I said, you can of course use other tools for retouching. But for example, Visual Studio Code, there's a plugin, you can do it text-based. So when you directly want to edit as a programming level, you can do this. But the thing what I showed, it was Gestalter. And I think that answer it. There are today not so many tools regarding this out there, because for me, in that concept of glTF, you're importing somewhere or exporting, it's not retouching anymore. It's like you're reprocessing it. You're going back step and like this. Regarding sound, there's a Khronos audio extension, and it's originally from the from Robert Long, like all this group he's behind it, from Mozilla, ex-Mozilla people. The point is, technically it's ready, but I think that the point why it's a little bit stuck is because of the metaverse standard form. Because in the first step, there was a great idea of this audio extension, but and also like we have it in our tool. But the point is that because of the metaverse, people have more requirement and there are different approaches. So that's the point where like it takes more time to discuss and agree like on the parameters. So it has been restructured from the, yeah, it's nice for sending the link. It will come, but the point is the more people are using glTF, more people are discussing about glTF. So it normally takes longer time until it's released or ratified. But in the end, that's the good thing, because glTF is an ISO standard that you can rely on, that it's well tested, people have thought of it, and the glTF will run everywhere. So the point is it will come into Blender. I think Julia Duvaux, who's currently maintaining The GTF Blender import exporter, I think, is ready to go as soon as it comes. But the point is, like, it has first to be ratified to make it sense. If there are any other further questions, quick questions, please let us know. Otherwise, I would give over to Lizzie and to make a final roundup.
Well, thank you, gentlemen. Those were wonderful presentations. We appreciate your time and effort in putting together today's webinar. As a reminder, a recording of this presentation along with the slides will be available on the Khronos Group website, and a direct link will be sent to you in a follow-up email. As you leave the webinar, please take a moment to fill out the survey that pops up. Your feedback is important to us to help us improve these presentations. Please let us know if there are other Khronos-related topics you may be interested in, and thank you for joining us. We hope you enjoyed the webinar. Have a great day.